Okay, for this problem we have 3x squared minus 10x minus 8. So let's see, we're trying to think of what are the two factors of 3, which is 1 times 3. For 8, it could be 1 times 8. I'm going to try 2 times 4 first. Okay, let's see. We need some combination of products that's going to add up to negative 10. And if I had a negative 12 and a positive 2, that adds up to negative 10. So that's the combination of products that I want. Now, these numbers go in the front of our parentheses because those are the factors of the first term. So I'm going to take 3x times 1x, and I can just write that as x. Okay, and now these numbers are the products of our last term, so they go at the back of the parentheses. Now, I needed 3 to multiply times 4, but it really needs to be a negative 4 because I need that 12 to be negative in order to add up to a negative 10. Okay, the 3 multiplies times the first term. That's how I get my 3x squared. And then the only other thing it multiplies times in the second parentheses here is this last term. So since I want 3 to multiply times negative 4, I'm going to put my negative 4 in that outer position. Okay, and now I needed 1 to multiply times 2. This is like a 1x in the front here, that 1, and so that needs to multiply times a positive 2. Okay, now when we check these, so this right here would be my answer, and then I can check it by distributing. So I can check by taking 3x times x, so that'd be 3x squared, and then 3x times negative 4 would be a negative 12x. 2 times x would be a positive 2x. And 2 times negative 4 is negative 8. And notice that these middle terms add up to a negative 10x. For this next problem, I've got a binomial, so 1, 2 terms, and I'm looking at a cubic term there. So I need to use my formula for the sum of cubes. And that formula is a plus b times a squared minus ab plus b squared. And this is a really important thing to have in your notes. Okay. There's also the formula for the difference of cubes, which is a minus b times a squared plus ab plus b squared. And these are just formulas, and we just need to know them and be able to apply them. Okay, I'm going to choose this first one because of the addition sign here. Okay, so I need to use the one that has addition. And so in this case, the a in this case would be x, because it's saying something cubed, and in this case it's x cubed. So every time I see an a in my formula, I'll just write that as an x. And then the second thing, what's cubed here, is 2y, because 2y cubed is 2 cubed is 8, and y cubed is y cubed. Okay, so we're looking at each of these terms and trying to figure out, well, what is being cubed here? Okay, so that's the first thing, is to figure out what our a and our b are, and then I'm going to just simply go through step by step and copy this formula down. A plus b, I'm just rewriting this so I can actually use it, ab, and then plus b squared. Okay, I've decided that a is x and b is 2y. Okay, so every time I see an a, I'm going to just replace it with x. Okay, so this is an x in my formula, but an a in my formula, I need to replace it with an x. And this b, I'm replacing with 2y. Okay, this a is replaced with x, and then I need to copy down the squared. Then I need to copy that minus. Okay, then I need to put in what what my expression is for a, which is x, and then my expression for b, which is 2y. And then it's always plus b quantity squared. And then we just clean this up a little bit if we can. In this case, I can simplify x times 2y, and I can rewrite that with the 2 coming first, and then times xy. And then here I can square both things. So 2 squared is 4, and then that would be times y squared. Okay, so I don't have to do much deep thought here. I'm simply using one of those two formulas, and I choose them based on if it's addition or subtraction. Okay. Okay, on this problem I see that I have two terms, 1, 2. But I'm not seeing any cubes. Okay, that's a fourth, and so it's not going to be the difference or sum of cube formula. So instead, let's see what we've got. First of all, I notice both these numbers are even, and so I'm going to factor out a common factor of 2. 32 divided by 2 is 16. 2 divided by 2 is 1. Okay, so notice that would be the opposite of distributing there. Okay, so I'm going to pull out my 2. And now, if I rewrite this, if I had a problem 4x squared plus 1 times 4x squared minus 1. That's how this ends up factoring. Now, how did I know that? Well, this is the difference, because it's subtraction, of perfect squares. 16x to the fourth, that 16 is a perfect square. That's, 4 times 4 is 16. X to the fourth is a perfect square because x squared times x squared is x to the fourth. This would be 4 squared, and then x squared quantity squared. That is 16x. We get to multiply here to the fourth. So that is a perfect square. And 1 is a perfect square as well. 1 times 1 is 1. The way that we factor those is we take the square root of the first term plus the square root of the second term, and then the second parentheses is exactly the same things, except we have addition in one, subtraction in the other. Okay, so that's how we're going to factor it. Let me just show how I would check that. Okay, so I'm going to take and distribute my 4x squared to both terms, and then I'm going to distribute my 1 to both terms, and then I'll distribute my 2 at the end. Okay, so 4x squared times 4x squared, we just showed what that is, which is 16x to the fourth. And then 4x squared times negative 1 is a negative 4x squared. Positive 1 times 4x squared would be a positive 4x squared. And 1 times 1 is 1. Positive times negative is negative. Okay, and notice these middle terms are exactly the same, except one's negative, one's positive, and so those are just going to add up to 0. Those cancel out. So I have 2 times 16x to the fourth minus 1. And when I distribute my 2, I would get 32x to the fourth minus 2, which is what I started with. Okay, so my check shows that the way that I factored this is indeed correct. So there's the correct factorization. So the general form for a difference of squares is we would take a plus b times a minus b. So those are my those I love to factor those. Those are my favorites. Okay, so here we're going to be factoring, and we're dealing with all kinds of negative exponents. So for me personally, it's a little bit easier to see this if I write these as fractions. The negative exponent would bring that down to the denominator. Okay, and so now we have 9 over m to the 5th. Okay, so first I'm going to write those with positive exponents by bringing the negative exponents down to the denominator using those reciprocals. Okay, now what we can end up doing is we're going to factor out the smallest thing, which is the term with the biggest denominator. Okay, I just want you to look at something for a second. If we had, let's see, we have half a chocolate bar compared to 1/10 of a chocolate bar, right? Okay, the 1/10 is the smaller amount. Okay, so if we're taking this one chocolate bar and sharing it among a lot of people, 10 people, we get a smaller amount than if we just had that one chocolate bar and we only had to split it with 2 people. So the more people we're sharing with, the bigger the denominator here, the smaller amount we get. Okay, so the smaller fraction here is m to the 5th. That's what we're going to factor out. Okay, and let me just show you what we end up getting, and then I'll show you why. So we would get m squared plus 10m plus 9. Okay, and why is that? That is because here, if I'm trying to tell you that 1 over m cubed is the same thing as 1 over m to the 5th times m squared, that first term right there. Well, is it? Let's see here. I have a fraction times a number. I'm going to give my number a denominator of 1 and then just multiply straight across. So in the numerator I have 1 times m squared, so m squared. The denominator I have m to the 5th times 1, so m to the 5th. And then that does indeed end up being 1 over m cubed. Okay, so, right, because we have m squared, which is m times itself. And then m to the 5th is m times m times m 5 times. Anything divided by itself is just 1. Okay, so I have 1 times 1 in the numerator. There's my 1. And then I have m times m times m, so m cubed in the denominator. So that is equivalent to this first term. Okay, and notice if I started with 3, I'm factoring out 5, what's the difference there is 2. Okay, and so then if I was going to check here, y is 10 over m to the 4th. 10 over m to the 4th, is that really the same as 1 over m to the 5th times 10m? And you can do the same thing that we just did down here and convince yourself that that's true. We would multiply straight across and get 10m over m to the 5th. One of these would cancel out with 1 from the bottom, and we would get m to the 4th in that denominator. Okay. All right, so that's what we do, is factor out the smallest denominator there. And then I need to factor m squared plus 10m plus 9, and that factors out, I'm going to copy down my 1 over m to the 5th. That would factor as m plus 1 and m plus 9. 9, the factors of 9, we could have looked at 3 times 3, but we need those middle terms to add up to 10, which is what happens when we take 9 and 1. Okay, so that's my final answer. And that's also equivalent to writing it as just a fraction here. If we had m plus 1 times m plus 9 in the numerator, and then what's in the denominator is m to the 5th. Okay, so those are both equivalent. All right, let's look what we did. We factored out the smallest term, which is that m to the 5th. Out it came, and then we looked to see, can we factor what's left over? In this case, we could. All right, and that's done.